Do you remember the Portal game? Thanks to RayPortal BSDF, you can create your own portals in Blender. Unfortunately, to create the setup, you need to know a bit of geometry nodes, and explaining the effect would be too advanced for this tutorial, so I will just quickly explain what does the shader do. It's basically a transparent shader, but it transports light rays in one direction to another location in the scene. That means besides portals, you can create a CCTV camera effect, orthogonal projections, and many, many more. Let's create a simple CCTV camera effect. I split my viewport to have a camera view on the left and to see the whole scene on the right. In the left bottom window, I have an UV editor opened, and we'll get to this in a minute. I have a few objects lying around here and a camera that I position to my liking. We need to create a simple plane, and we'll treat it as the TV screen we want to have the camera view on. I will move it aside and scale it a little bit, and then accept the scale by pressing Ctrl A and scale. Let's add a RayPortal shader. In this node, we have two inputs to tell the shader the position and direction of the rays we want to transport. Let's start with a bit more complicated one, which is a direction. In our case, it will be rotation of our camera. We haven't really talked about UVs and unwrapping yet, but let's say that we need to use the canvas of our plane to display a view from camera. To simplify, we'll project the camera view to our plane. So our plane needs to have the UVs to be able to project the camera view. Fortunately, after creating the plane, it's automatically unwrapped, so we don't need to worry about it. You can see the unwrapped plane in the window on the bottom left. I will join my shader editor with the UV editor because we don't need it anymore. Now, we need to center the coordinates, so we need to add a value node. Here we'll set 0.5 value on X and Y axes with a value node, because we want to have our camera projection in the middle of our plane. Our screen has two dimensions, so height and width, and we need a third one, and it will be a focal length, acting like a depth we're looking through a camera. I will copy this value node and set it to 1 for now, and we'll play with it later. We need to combine these values, and because we're working on vectors, which have 3 inputs for X, Y, and Z, we'll use the combine XYZ node. Then we need to add a texture coordinate node because, as I said a few minutes ago, we are using our plane as a texture, so we need to know the UV coordinates. We'll add a texture coordinate node and we'll subtract our combined camera position from UV coordinates using the vector math node. Now, to actually convert this data to rotation, we need to add a vector rotate node. We can find it here. Shift A, vector, and vector rotate. We need to change type to Euler because we want to have access to all 3 axes. Hold tight, we're almost there. Now we need to plug our coordinates to vector input of vector rotate node and type the rotation from our camera. So for X, it will be 70, for Y, 0, and for Z, 2.1. Now we can plug it into the direction input and we see something, but it's definitely not a view from our camera. Last thing we need to do is to set the position of the camera. So we'll take another combined XYZ node and type in the location of our camera. So X position will be minus 0.004, Y minus 9.64, and Z is 4.78. We can plug this into the position input and we're finally done. You can set a tint to, so it looks more like a dirty screen. It's a really cool effect, but definitely requires a little bit of vector math knowledge. Play with parameters a bit. See what changes when you change the position vector, and then let's take a look into the little bit easier to understand nodes, sheen and toon shaders.